This is the video for the walkthrough for the Pure and Mechanics paper. What I want you to do is you should have the exam paper in front of you. I'm going to go through how to do each of the questions on the board now, and you should be completing these as we go along, okay? So, do feel free to pause the video at any time and re-watch the specific question, and I may well split the video up into several chunks so it's not too long. Right, so let's get cracking into question 1. So it is this question about the perpendicular line. So straight away, reading the question carefully, we're told that we have we want to find the equation of the line that's perpendicular to y equals 2x minus 5 that passes through the point 4, 1. So straight away, I'm thinking that my gradient is negative reciprocal, so minus 1/2. The gradient of this line is 2, so the gradient of the perpendicular line is minus 1/2. So I know my perpendicular line will be y equals minus 1/2 x plus c. If it goes through this point, I know that the y coordinate is 1, minus 1/2 times the x coordinate is 4, plus c. So minus 1/2 times 4 is minus 2. So c must be 3. So my final answer then is y equals minus 1/2 x plus 3. Let's just check what the form I need to give it in is y equals ax plus b. And that's the way I've got it written at the moment. So I don't need to do any rearranging. So there we go, there's that question, done. Moving on to question 2. We need to find the coefficient of x cubed in the binomial expansion of 2 minus 4x all to the power 5. Okay, so you do get given the formula for the binomial expansion on your formula sheet. So let's write down the first few terms of this. So this is what the formula says. So it's a to the power n plus nc1, a to the power n minus 1 times b, plus nc2, a to the power n minus 2, b squared, plus dot, 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 dot. That's what the formula says on your formula sheet. If we're using it in this case, a is 2, b is minus 4x. Notice the b has got to be a minus 4x there. And n is 5. So a is 2, b is minus 4x, n is 5. So let's just substitute those into the first few terms here until we can find the x cubed term. Then we can see what the coefficient will be. Okay, so the first term is going to be 2 to the power 5. The second term, so nc1, so that's 5c1, 2 to the power 4 minus 4x. Notice I'm using brackets around these terms because otherwise it can get quite confusing, especially with the minus, especially when we start having powers as well. So make sure you use brackets around each term. The next one will be 5c2. Then I'm going to have 2 to the power 3 minus 4x squared plus the next term would be 5c3, 2 to the power 2 minus 4x to the power 3. And I'm actually going to stop there because I'm going to get my cubed term. I'm going to get my x cubed here. So I'm not going to keep going. Remember, all I'm interested in is the coefficient of x cubed. So all I'm interested in is this term here. So what I want to know is what is 5c3 multiplied by 2 squared multiplied by minus 4 to the power of 3. I'm not too bothered about the x cubes there because all I'm interested in is the coefficient. So, working this out, you can use your calculator to do it. 5c3, if you type that into your calculator, you'll get 10. 2 squared is obviously 4. Minus 4 to the power of 3 is minus 64. And if you type that into your calculator, you will get minus 2,560. So, that would be the coefficient of x cubed in that expansion. Okay, moving on to question 3. Okay, I've got a question about bearings. And we were told that we have the unit vectors I and j pointing in the east and north direction respectively. We want to calculate the bearing of minus 4i minus 6j. So, if north is straight up, minus 6i, so that's going to be, minus 4i is going to the west. If I is going east, then minus 4i is going to the west. Minus 6j, well, that's going to be going south. So I'm travelling in this direction. Let me use a different colour. I'm travelling in this direction. And what I want to know is, what is the bearing of that vector? So what is this angle there? So, if I work out this angle here, I'll call that phi. I can then take that angle away from 270, and that'll leave me with my bearing. So to work out that angle there, I'm going to do tan of phi is equal to the opposite, which is minus 6, divided by the adjacent, which is minus 4. So phi would equal tan inverse. If I type that into my calculator, I'm going to get 56.3099. So my bearing then, theta, would be 270 minus that answer, which is going to be 214 to 3 significant figures. Okay, so that's part I of that question. Next part, part II. We're told that the vector minus 4i minus 6j plus k times 3i minus 2j is in the direction of 7i minus 9j. And we need to find the value of k. So, first of all, the direction 7i minus 9j. So 7i in this direction minus 9j in that direction. Right. So let's mark on that direction. So this vector is in the same direction as that vector. So let's have a look. How much does this vector go across? Let me use a different colour to compare this there. So I've got minus 4i plus 3ki. So minus 4i plus 3ki. And acting downwards, I've got minus 6j minus 2k j. Right. So I know that tan theta would equal opposite over adjacent, so minus 9 over 7. And that's also going to equal my minus 6 minus 2k over my minus 4 plus 3k. Obviously, when I'm writing out an equation like this, I don't need to include the i's and j's. All they're doing is showing me the direction. It's not telling me anything about the size of these lengths of the triangle. So don't worry about using the i's and j's in this equation. So the point is, by doing this, I've now got an equation over here, because I know theta's got to be the same for both of these ratios. So I've now got an equation here. I can rearrange this, so I'll have minus 9 times minus 4 plus 3k. It's going to equal 7 times minus 6 minus 2k. So that's going to give me, multiplying those together, you get 36. Multiplying these together gives me minus 27k. Over on the right hand side, I've got minus 42 minus 14k. So collect up, that's going to give me 78 over here, adding the 42. Adding the 27 over here is going to give 13k. Therefore, k is going to be 6. And we're done. Okay, one more question in this part of the video. Question 4. Okay, we have been asked to express 3x squared minus 12x plus 5 in the form of in the completed the square form, basically. It then says to hence states the minimum value of y on the curve. Okay, so I've got 3x squared minus 12x plus 5. Now, in order for me to complete the square on this, I don't want there to be a coefficient of the x squared. So I'm going to have to factorise that 3 outside. So that'll just leave me with an x squared here. That'll leave me with a 4x here. Because the 5 won't divide by 3 easily, I'm going to keep that separate over here for now. We'll come back to that in a minute. So I've just factorised the 3 out here and here. I can now complete the square on what's inside this bracket. The 5 will just stay over there at the moment. I'm not going to do anything with that 5 just yet. So completing the square here, I'm going to get x minus 2 squared minus 4. Now, multiplying out, I'm going to get 3 times x minus 2 squared. 3 times minus 4 is minus 12. I've still got that plus 5 over there. And I can now collect up my like terms here. So I will get 3 lots of x minus 2 squared minus 12 plus 5 is minus 7. There we have it. So, I've written it in completed the square form. And it says, hence states the minimum value of y on the curve where y is equal to that expression. So the minimum value here is going to be, when x is 2, I'll get 2 minus 2 is 0. So this whole thing here will be 0, times by 3 will be 0, so all of that is 0. And the y will just be minus 7. So this is my minimum point. There we go. So those are the first 4 questions on that assessment. Watch the second part of the video and we'll carry on with this assessment.